Hi, this video has some examples on down payments and using the different formulas in a spreadsheet. So let's read this one and see which formula we'll be using. It says you're saving for your 3-year-old child's college fund and you want to put in $2,500 now and make payments of $50 per month for 15 years at 5.2% interest. How much will you have saved in 15 years? And of course, we want to keep showing our formula with all our inputs. Okay, so I usually go to the question first. So what am I trying to find? How much will you have saved in 15 years? So that is the future. So we're actually looking for the future value. So I'm going to I know I'm going to do my future value formula. How much will you have out there in 15 years? Okay, now everything else, let's see what else. So our rate is 5.2% interest, and we're making monthly payments. So I know I have to divide that by 12. So the rate, looking at my formula here, the rate comes first, 0.052 divided by 12. Number of periods, 15 years times 12 months. The payment is $50 a month. What I'm looking for is, do we need to use this 3-year-old? Is there some calculation we need to do? So let's double check this. You're saving for your 3-year-old child's college fund. How much will you have saved in 15 years? Okay, so we don't need to do a calculation with that. If it said, how much will you have when your child is 18? Then we would have had to go 18 minus 3 is 15. But they actually gave us the 15 years. So you might have to do some kind of calculation in the middle of this. Okay, so for our future value, it's the payment. We're making $50 per month, and then the present value, we are putting in sort of a lump sum or a payment now. So the future value is $2,500. So I guess rather than a down payment, this is like a lump sum payment now plus monthly payments. Okay, let's see what this is. We have equals future value, 0.052 divided by 12, 15 times 12, $50 per month, and $2,500 down. $19,000. $19,034.49. So this was similar to one we did before, but here we're saving the money rather than paying off. Okay, so we would have $19,034.49 in 15 years. Okay. And last one, feel free to try this yourself and pause the video and then compare answers. You want to buy a car for $11,000 and you trade in your old car for $1,500, which acts as a down payment. The car loan interest rate is 2.74%. What will your monthly payments be if you choose a 2-year, 3-year, or 4-year loan? Show any calculations in Excel formulas used. Okay, it's a great real-life problem. I want to buy a car and I want to see what the different payments would be to know. I don't want to stretch it out too long, but I want the payment to be affordable. Okay, there is a calculation we need to do up front here because The car, we're buying the car for $11,000, but we're trading in $1,500. So we're actually not going to need to borrow the full amount. So we only need to borrow $11,000 minus $1,500. So let's sorry, I gotta get back to my spreadsheet. Okay. Let's just use Excel as a calculator. You could probably do that one in your head though too. Equals 11,000 minus 1,500 is 9,500. Okay, so now we also could have done that inside of a formula, but I'd rather just have that number done. Okay, so now we're going to use a formula, but which formula are we going to use? So find the question, what will your monthly payment be? So this is a payment question. Payment, okay, so I gotta find my formula here. Payment, so the rate goes first. 0.0274 divided by what? Monthly payment, so 12. Then our number of periods. Okay, this is what will be different, right? Because 2 years is 2 times 12. And then our present value, we want to buy the car. So the car right now, or our loan value is $9,500, and we want it to go down to 0. So that's our payment. And then this is the only thing that's going to change from 2 to 3 to 4. Everything else, because that's just 12, everything else will be the same. Okay, so let's try this one out. So equals payment 0.0274 divided by 12. 2 times 12. 9,500, comma 0. Okay, so if we pay the car off in 2 years, it's 407. Actually, I'm going to go this way because I can see I'm not going to have room to write that formula. 407.23. And then let's go down. What if we do this in 3 years? So payment 0.0274 divided by 12, 3 times 12. We'll get that number, and then 4 years, different color. That would be 4 times 12. Now, I don't know, I haven't shopped around for cars lately, or car loans lately. If you have a different length of your loan, I don't know whether the interest rate will change. Maybe you know that if you've been in this situation recently. I'm not sure. So let's go in. This is a good chance where we can just edit our formula. Change that to 3, enter, boom, we're done. That went down to 275.18. Not bad. And then let's tap on it again and change the 3 to a 4. The spreadsheet's nice for that. You can just edit your formula. That went down to 209.19. So let me just fill out so that we know, since I switched the order here. So this is for 2 years. I gotta put per month in there. per month for 3 years, and this amount per month for 4 years. So what do you think? Which payment would you choose? 4 years, the payment is definitely a lot lower, but I wonder if you're paying more interest overall. So maybe you want to go, maybe you want it to be paid off as soon as possible. So you want the biggest monthly payment you can afford. I don't know. It depends. It's very personal to your situation. All right. So there's an example where we're calculating the payment, but we have a down payment. So we could also use this for a mortgage. Also really nice to be able to calculate your own mortgage payment. Okay. That's it for this video. I'll see you in the next one.